Now, what I'd like to do in this one a little bit more is take on the idea of how is math being used in the social sciences? Because that's where a lot of our students are they are in the social sciences. So social sciences often deal with human behavior and the choices that people make, obviously. And that seems much tougher to get a handle on at first glance. Well, we think that behavior is unpredictable, and certainly with certain individuals in our classes or whatever, it is. Behavior for individuals, what an individual will do, can be very difficult to predict what is happening. But is behavior outside the realm of math? And if we can model people's choices, can we make, is that one way to predict behavior? Most of our students major in humanities or social sciences, and there's a tendency, I don't need to know math. In fact, unfortunately, that's kind of the reason some of them go into the social sciences, right? They start out, I want to be pre-med, I want to be an engineer, and then they hit pre-calc or they hit calc 1 or wherever the log jam is, and they say, I don't know, but I don't want to be that because I got to know math. And so in a certain sense, it's a way of escaping math. But the way things are going, I don't think people are going to be able to escape math, basically. It is just starting to permeate all of society. And math is really important, and I think what I'm trying to do here a little bit more is concentrate on the big picture of all of this, rather than just, sometimes with math we got a really strong curriculum, a lot of skills, and sometimes it's nice to just sit back and look at the big picture. That's the idea of this here. Modeling social situations. Well, here's the old Venn diagram one. We've all probably have done this. We got a Venn diagram and we say, okay, the yellow circle, let's say that's college algebra students, the blue circle, that's trig students, and then the green would be what? That would be taking both. Well, you can turn it around a little bit here. You can tell the students, okay, well, yellow is people wearing sandals, blue is wearing socks. Then you ask, okay, who's in the middle? And they'll say, my dad, right? It's the same idea, but it's just in a little different setting. There's a famous example that they use. They use it in terms of modeling. They use it a lot of times like in economics and that as far as mathematics. And what it is mathematics can predict the next shot that an excellent pool player will take with a high degree of accuracy. And at first glance you say, well, yeah, I believe that. Math can do that. But there's a little bit more to it as I started thinking about it, and why people think about it is, well, okay, there's important questions. Now, does this mean that the pool player is actually doing trig, algebra, vectors, and properties of physics to figure out the next shot? Well, most of us who know pool players would say, well, probably not, right? Somehow they're doing it, but they're probably not doing the equations and the math in there. Okay, now we're modeling, and so the question sort of becomes, well, but does this mean that our mathematical model is incorrect then? If the pool player isn't doing it, but it works, is that still okay? Well, like any good engineer, if it works, you use it. And what is going on here? There's sort of a subtlety that, okay, somehow then what's happening is when we model something, math is not modeling reality, but somehow math is modeling the player's choices. So whatever is happening, there's sort of this equivalency. And mathematicians certainly understand equivalencies. There's something that's going on there that's equivalent. And in fact, there are people that are starting to say that, look, the universe, what it is the universe is really mathematical. The rest of it is projections that we interpret differently, but it is really mathematical, that you can interpret the universe in terms of mathematics. Modeling non-rational choice. Now, that pool example, that's pretty rational. That's like, I got to get the correct ball in the correct hole in that. So losses and gains. So let's take something that's less rational here. All right, is it better to give your significant other 2 $100 presents or 1 $200 present? Okay, who's for 2 $100? 1 $200. Doesn't matter. Well, see, that's a mathematician speaking there. We'll probably say it doesn't matter. Well, they do some studies on it, and 2/100 tends to be a little better. Okay, here's another one. Next question. If a person wins $50 and then gets a $25 parking, when they go home, do they feel happy? No, right? Okay, but in a certain sense, they're 25 bucks up. Well, why don't they feel happy?
Because they got the parking.
I lost 25 bucks. People tend to concentrate on the 25 bucks. Now, it isn't exactly rational. And people weigh losses significantly more than they do gains, about double. And so people demonstrate, and marketing people know this, loss-adverse behavior. People do not like losses. Well, can we model this at all? This almost seems non-rational, but we can model it with the following value function. And what's interesting about this value function is it's concave. And so let me just try to explain this a little bit. Let's take the two gifts. Okay, now what this is on the x-axis, this would mean this is like winning money, getting refunds, rebates. This would be paying for something. Okay, and this one here is kind of nondescript a little bit, but I feel good, I feel bad kind of type thing. All right, notice no hash marks exactly on it. Now you can see here, because of the concavity, if you say, okay, 100 bucks is here, then you give the person a $100 gift, they get, a little feel good. And then you give them another one, and they feel good. But because of the concavity, if you go out here, say that's 200, you go over, yeah, it's more, but it's not twice as much. If you take the parking ticket and the winning 50 bucks, okay, because now the thing is, notice it's not symmetric either, is it? So if you let's say you win 50 bucks, so we get, a little bit out of it, but then we got that $25 parking ticket, and it almost balances out. And it's a little bit the way people look at it.